Grace.
Okay, so we're live.
Sweet.
Hello, I'm already in the quiz.
Okay. So we're gonna do the quiz now, right?
Yeah.
Yeah.
Here we go. 17 questions again. I completely, yeah, true. Number 3, the symbol for the true population proportion is?
It's just P, isn't it?
Yeah. No. I don't remember. Because wasn't the last one this question?
I have written down P equals population proportion.
Okay. Let's do it.
No, just
Yeah, just P.
like I have P equals population proportion, which is the parameter of interest. And then I have written down that statistic to estimate P based on the sample P hat. So I think
You do anything since last week.
So I think we're good.
So is it P or P?
Yeah. It's
Okay.
P because the P hat is the equivalent of X bar, and that's a statistic to measure something you don't really know. So the actual parameter is P equals U before. So it's definitely. Hello?
So P?
Yeah, it's
Definitely P. Okay, just plain old P. No hat, no swiggles.
No.
For question 4, the requirement. So you suppose for 4 and 5, suppose n equals 20 and p equals 1 over 4. Requirements for constructing a confidence interval satisfied.
I just have that it needs to be a simple random sample, and then NP needs to be greater than or equal to 10.
10, isn't it? Yeah.
I think.
So
NP equals 10? Greater than or equal to 10?
Size of the null
20
hypothesis.
times 0.25 is going to give us 5, so it's less than.
Are we sure we're doing that right, though?
Mm-hmm. No idea.
I feel like there's not enough information.
I agree. Where's that option?
Well, so if you work it out, if you go n times 1 minus p, that gives us 15, right?
Yes. See, that's what I was thinking. That's greater than
so
10, which makes it.
So our NP would be greater than or equal to 10.
Yeah. So that's true. That's requirement is met.
So it's true.
That's what I'm thinking.
What I really want to write in there
Well,
is this a simple random sample? Because if not,
right. That's the only thing is it doesn't say that it's a simple random sample.
it's good. But I'm sure that it's usually implied, so most of them.
Oh, for confidence interval.
So we're good. So we're good.
I think it's true. It's satisfied.
Oh, for confidence interval.
Yeah, I know.
The requirements for conducting a hypothesis.
I think that's the one we just figured out.
Yeah, I know. No.
Confidence interval. My confidence interval notes talk about the squiggle plus or minus the critical value times all that other stuff, you know? And they do like the, what do they call it? The plus 4.
As long as
Like what I have written down is that to figure out for the p squiggle, which is one of the keys in the interval, it's x plus 2 over n plus 4.
yeah, well, it says in the requirements, like on 2.1.2, that as long as n is greater than 5, that can be.
Yeah, we should be good then.
So yeah.
Confidence interval is fine, but is the hypothesis test satisfied?
Yes.
Yeah, we did that
That's
the
when we
first-
just figured it out.
Okay. 6. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. 45 of the defendants were found guilty. Here's the information for question 60. Find P-squiggle. What's that called?
It's P tilde
Tilde.
T-I-L-D-E.
Okay.
Tilde. We could just call it P-tail,
P-tail?
but it seems simpler. P-tail.
Yeah. Okay. So find P-tail. The plus 4 made out of the portion of the defendant were found guilty in this state. How do we figure that out?
Well, I know that in order to figure out for the P, it's x plus 2 over n plus 4.
Yep.
So what's x?
So x is going to be the number of.
The 45.
Yep.
So 45 plus 2 over 60 plus 4. Is that right?
Yeah, so
Yeah.
45 plus 2, so 47.
Over 64.
So 0.734.
734.
And P hat.
That's just x over 100. I mean, x over n.
0.75. Create a 95% confidence interval for the true proportion of first-degree murder trials in the state. In the state where the verdict is guilty. So 95%. Okay.
So for 6, we got 0.734, right?
Yeah.
And
Yep.
then we're doing 7 now, right?
Which is x over n, so it's 45 over 60, so 0.75.
Well, sorry, mine glitched and I could barely hear you guys.
Okay. 0.75.
So then, in order to figure this part out, it's the little p-tail thing, plus or minus. If it's 95% confidence, it'll be 1.96 all over, or times the square root of p-tail times 1 minus p-tail all over n plus 4. And
Yeah.
Okay. Sorry, I'm kind of lost on this one. What do you guys have?
I'm almost done with it.
We're trying to get the margin of error, right?
So our bottom one is going to be 0.640 or 0.641. There's a 0.640, so I get 0.6406 for our bottom one.
For the top one, I got 0.73997.
Let me do my tops. For my top, I get 0.827.
I got 0.740. So can I just read mine back to you?
Yeah, let's start with the equation that we're using too. Make sure we're all got the right equation.
So I have p tail plus or minus the critical value, which is whatever, 1.96.
Or z, yeah.
So then it would be times the square root of p tail times 1 minus p tail all over n plus 4.
Correct.
So 0.734 minus, or times 1 minus 0.734 all over 64, and the square root of that, I got 0.003.
That's what I get.
And then I multiplied that by 1.96. And then I just added that to 0.7 originally.
What was your square root of your 0.
That was my square root, 0.0.
That was your square root?
I think. I thought it was.
Because I did the 1 minus 0.734 and then times the 0.734. So you get 0.1952 over 64. And when I did that, I got 0.003.
Damn. So the top is 0.266, and then I equals 0.00415, and then I'm going to take the square root of that, and I get something totally different than I got the first freaking time. So then I get 0.064. That whole square root issue. So then it looks like the value that we're adding and subtracting to our p tail is 0.1.
So did 0.76218. That's the got where I got from my high. Did anyone get 0.76218?
Wait, what did you get?
I got 0.76218. And then I got 0.70582. I think that's how I like really broke it down though.
See, my top value is 0.86, and then my bottom value is 0.6. that an option?
Dude, I didn't get any of that. What the hell?
I got a lot of 9s. Those were like my first answer.
0.6997 for my bottom, which isn't an answer. It just stinks.
See, and I get for my upper 0.827.
What are we doing? We should add up our answers and then take the average.
Yeah, 0.768 for my upper. I don't know what the heck happened.
See, and for my lower, I get 0.640.
Okay, I think I finally figured out what I did. Hang on. So that is square root. So then I'm going to times that by 1.96. So the value that we should be adding and subtracting is 0.108. Everyone
It's not a
add.
P.
What?
It's not the 0.734.
No. That's the main number.
Uh-huh.
So we're adding and subtracting 0.108 to the 0.73. And that should be the right answer.
0. Where'd you get that?
I just did the math again. So the upper one should be 0.842, which maybe
Which there's the 8.3.
yeah, so that's probably it, because I probably just rounded mine too. And
What's the
then
bottom end?
the bottom one should be 0.626.
Yeah, that's like the third answer.
Let's go with it.
Wait, so
I'm
what
really
were you talking?
I'm
What
really
were you talking about? Adding?
So a confidence interval is just a certain distance away from either direction of what the mean was. So in this case, our p-tail.
Uh-huh.
So with that whole square root timesing it by the critical value, I got rounded 0.108. And I'm very confident.
Oh, I think I got a 0.108 too.
Okay.
Easy.
Let's go on to question 9.
Yes, I agree.
It's 10:30 here. I'm
Yeah.
dying.
9. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
Oh, there's right here. As confidence increases, your interval, the width of your interval increases.
Wait, no. No. It says the sample size increases. So if you increase the sample size, what do you expect the interval to do? And if you,
The width.
as it increases, the interval decreases. So decrease.
Yeah, it'll
Everyone
decrease.
So 9 is decrease?
Yeah.
For sure.
For sure. All right, 10. To conduct a hypothesis test for one proportion, 2 requirements must be met. P equals 1/2. What is the smallest n can be, and both requirements must be met?
So what do we decide?
The smallest n can be that both requirements are still met. We've got NP is greater than or equal to 10. 0.5 times 20. And or what is it? N times 1 minus P. So N times 0.5 greater than or equal to 10, 20. Okay, so 20, right? 20 is the smallest.
Yeah.
That's the hypothesis test for one proportion. 2 requirements must be met. Suppose P equals 1/10. What is the smallest n can be, and both requirements still be met? So 100 and I think it's 100, right?
just
Sorry,
multiply
my
by 5. That's kind of
Does
different.
100 sound right?
Yeah.
Okay, 12. For questions 12 through 17, use the following information. For the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level of alpha equals 0.05 with the following hypotheses. The null is p equals 0.6, and the alternate is that p is less than 0.6. They collect new data this time, and n equals 80, x equals 38. Indicate good health. Conditions for conducting a hypothesis test are satisfied. True or false?
Yes. N is large enough, and for the everything to be normal distributed, and it says
It doesn't say anything about it being random.
Hypothesis test is NP is greater than or equal to 10. And
yeah.
n times 1 minus p is greater than or equal to 10. And 80 is large enough to make that happen with 0.6. Because with 0.5, 20 was large enough. So it should be true. Right? For hypothesis test.
Yes.
Okay. What is p hat? X over 10, right?
I got 0.475.
38 over 80, right?
Yes.
0.475. Awesomeness. 14. Find the test statistic. Equals. So V equals p hat, which is 0.475 minus p. What was p?
Which is 0.6.
0.6 over the standard deviation, which is the square root of p, which is 0.6, times 1 minus p, which is 0.4. And then over
Your n.
Which is 80. I got negative 2.5. That doesn't seem right.
Okay, give me 1 sec. Let me pull the calculator back out. Okay. 0.6 times 0.4. Square root. .475 minus 0.6. So I have negative, for my z, I have negative 2.282. Is that what you guys got for z?
I feel like my brain's just fried. I'm having a hard time getting the same answer twice.
Well, sorry, what did you get, Matt?
Negative 2.282.
Yep, got it.
Sweet. Let's use that. What is the p-value for this test? So now
So are we
we
going below it or above it?
Below. It says what's the alternate is p is less than 0.6.
So it's 0.011.
Yep.
So we reject, right?
And that's less than 0.05. So we reject it.
Yep. So
Reject
there is sufficient evidence to conclude
the summary. Sufficient evidence concludes that the water quality in the area has decreased.
Yeah.
Wait, increased or decreased?
It's decreased, right? Because it's less than what the p-value is.
Yeah. So there is sufficient evidence to conclude that water quality in the area has decreased. Right?
Yep.
Wait, yeah.
I'm submitting,
Yeah.
so I'll
No, you're right. No, you're right.
5 is wrong. Change your answers.
Is that it?
Yeah. Okay. I love all you guys. I'll post those documents tomorrow.
Thanks, guys.
Okay,
I will,
good night.
See ya.
I'll get that.